team is back with another episode of Topical Explainers for the sixth chapter of CAIE, AES Level Pure 1 Mathematics. In this video, we'll be discussing all about series, and to simplify the topics and provide us with all the information we need, we have Pratyush here with us.
Hello guys. Um, Today we're going to be tackling series, which is, in some books it's separate as binomial expansion and arithmetic and geometric progressions, but on the syllabus it is point number 6 and it covers both of these. So we're going to be covering the binomial expansion, arithmetic progressions, and geometric progressions. Let's get started. This topic is sort of standalone in that you don't really need too much from other chapters, but once you start getting the past paper questions, you will need your quadratics knowledge. That's the minimum. And you definitely need to be comfortable multiplying terms across brackets for binomial, and need some prior knowledge, just a little bit, about sequences to begin arithmetic progressions and geometric. So let's get started with the binomial expansion. Let's see where this comes from. We've probably expanded brackets before. I mean, just quadratics chapter itself, we're going to be doing that a lot. But if we start looking at higher powers, like to the power 3 or to the power 4, then we end up with this pattern here. So let's just look at the coefficients for a second. The first thing you'll notice, this is a constant term and this is a variable term, and they're being added together. And we've multiplied the whole thing to power 1. So that means it's by itself. First coefficient's 1, second coefficient's 1. This is squared, and if we were to expand that, it means 1 plus x times 1 plus x. Wow. And you do the FOIL first, like that, and you just get all of the terms separated, which leaves us with 1 plus 2x plus 1. So again, just take a look at the coefficients here. That we'll get to the proper expansions later. I just want you to look at the coefficients. And as we carry down, you can see the pattern. It's not so clear when you're looking at it this way. So let's put it in a triangle like this. And let's make it more triangular. And this triangle here is called Pascal's triangle. The thing you should notice about it is that when you add these two terms, 1 plus 1, you get 2 here. And when you add the two terms next to each other, you get the term below it. So 2 plus 1, 3, 3 plus 3, 6, so on. And this pattern, Pascal's triangle, is the pattern that we use for binomial expansion. So when we want to multiply like 1 plus x to the power 5, then our coefficients will be 1, 5, 10, 10, 5, 1. Just like this row in the table. So let's fill in the next row just real quickly. 1 plus 5 is good. Actually, it goes outward, so always the first and last terms are 1. So that one's 1, that one's just 1x5. Wait, this is the wrong term. And then we add 1 plus 5, that's 6 here. 5 plus 10, that's 15. 10 plus 10 is 20. 15 again, and 6. So it does have a symmetry to it. You can learn more about the Pascal's triangle in a second, but for now, let's just think about what happens in an expansion if instead of 1 and x, we had a plus b to the power 3, let's say. Well, obviously we know that it would be, one of the terms would be a times a times a. So a cubed, and then the next term would be, there would be term with a squared and b, and the coefficient of that is given by Pascal's triangle. So we know that a to the power 2, and we're looking at 3 to the power, okay, so we're looking at to the power 3. So it's this row of Pascal's triangle. The first term has coefficient 1. We don't need to write 1 usually. Second term has coefficient 3. And then we have ab square, and that also has coefficient 3, and then b cubed, coefficient 1. So you'll notice that as the power of a decreases, the power of b increases. So it's just like they're both moving side by side. You need to be able to understand this pattern. As we go across, we move across the triangle for that row. Okay. So that's that. Now we're going to learn how to get Pascal's triangle without using a. Oh, not yet. We're going to expand some stuff first. So we just looked at how we can use the a plus b to the power something, power 4, let's say, to get something. So here's an incomplete Pascal's triangle. I'm going to just fill this in real quick. We add 1 and 1, add 1 and 3, 3, 1, 1, 3, and then 1, 4, 6, 4, 1. And that means it's going when you use the hint. Right, so remember, first we look at the terms that contain a to the power 4, and the coefficient of a to the power 4 is 1. 4 is 4 here, 6 is 6 here, so on. And you'll notice that a squared, b squared, so on. Right, so there's no nice way to explain this other than do it, so I'm just going to do it for you guys. So let's say a is 5 here for this one, and b is 2x. So if we apply this formula, we're going to get 1 times 5 to the power 4 plus 4 times 5 to the power 3. That's a to the power 3, and then b to the power 1. I like to put brackets around the terms so I know they're multiplying. Then we're going to use 6, the coefficient, and then we're going to use a squared, so 5 squared, and then b squared, 2x whole squared. This is an important part. Some people miss out, and they only put the power on the 2. But since b is all of this, we need to put power on all of that. And then we continue along merrily. Ho, 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 Christmas season. 2x, 3. Then we put 1, and then it's just b to the power 4, so x to the power 4. Now we can simplify this down a bit. 5 to the power 4 is, if my calculator will turn on, 625 plus 4 times. See, this topic, conceptually, binomial expansion is not hard. It's just because you're dealing with a lot of numbers is that it takes a while. Wait, where am I? 4 times 5 to the power 3 times 2. So this gives you 1000 x for this term. And then 6, wait, I'm simplifying. Wait a second. 6 times 5 squared plus.
It's going to be 600 x squared.
Okay, thank you.
Third term.
If you, yeah, I'll do, yeah, carry on. 4 times 5 times 2.
And the next one would be 160 x cubed.
60 x cubed. And then that's just 32, is it?
It's good. And then the next one would be, I think, 16.
16.
Yeah.
16 x 4. So basically, we just expanded this into that. Now, this is to highlight a point that if b was, I'll change color here. Let's do green. If b was to equal minus 2x, then we would have alternating signs. So look here. If this was minus 2, this is minus 2, this is minus 2, this is minus 2. Then here, it's minus 2 to the power 1. So that minus sign would stay here. That would be minus. Instead of, I'll write in a new line. 625 minus 1000x And then here, the minus 2 would be squared. So minus times minus, it would be plus again. 600x squared. And then here it's to the power 3, so it would be minus, right, minus 160x cubed. And again, to the power 4, you would have your positive sign. So this way, the signs can alternate if one of the terms is negative. Okay, so this is well and great. But what if you have some large value like 1 plus x to the power 10, let's say? Are you going to sit there and draw Pascal's triangle for 10 rows? Well, you can do that if you want to, but for the sake of time, there is a tool that we use. I know it looks scary. It looks like a big scary formula, but what it does is it gives you the row for Pascal's triangle. Um, little tip: n factorial. N has to means. Let's not do n. Let's do like 3 factorial. Means 3 times 2 times 1 multiplied by all the numbers down to 1. It has to be an integer. You will come across this NCR thing in stats, in permutation and combination specifically, because this formula, n factorial n minus r, is the way you choose n items out of r sets to make n items out of a set of r items. How many different ways can you choose a unique team, let's say, regardless of what the order doesn't matter. All that is confusing, but all you really need to know is how to use this in your calculator. Let's see if I can show my calculator. For me, it's down on top of the divide sign. If I press shift divide, it gives me NCR. And what I would type is, let's try some of these. If I try 6C2, I would type 6, shift, press the NCR button, press 2, and that would give me 15. And what this corresponds to on Pascal's triangle is on the 6th row, I go 1, it starts at 0, by the way. 0, 1, 2, 15. Now let's do 6C4. Then it also goes to 0, 1, 2, 3, 4. That is also 15. So you can, and if you do similarly, again, this notation just means, and same thing as CR notation. So you do 5C3, C3, that's 10. And since you know that it starts at 0, 6, anything C0 is 1. C3 is 20. And if you choose all 6 out of 6, there's only one way to do that. Okay. This is just a function in your calculator that you can use for the binomial expansion. No need to get your head worried about combinations right now. That's a whole nother game.
Also, it's
So
kind of
just
funny. I actually also don't know the formula yet. I don't have it memorized. I just use the calculator, and it does the work.
same. Exactly. I don't remember this. It's in the formula booklet if you need it, but I just recommend use the calculator. Come on. You don't get marks for showing that formula. You don't get marks for showing this formula, but you do get marks for showing the coefficient either as NR, or you can show it as NCR on your work. And make sure the values of N and R are there, obviously. Okay, so all that out of the way, we come to binomial expansion proper. Now, this is a big, scary formula here, and this is for when you expand brackets containing 2 terms and a power. And for this formula right here works for any value of, wait, no. This formula right here terminates, and that is why it's called binomial expansion, right? Because you can also have binomial expansions for non-positive integers, but we don't do that. We're just interested in like positive integers, 1, 2, 3, 4, 5, so on. Right.
Oh, by
And
the way, Pratyush, I actually wanted to ask you, is this not
uh
part of the P3 syllabus? This one?
this one is part of the P3, but I'm just, yeah, we don't use this. There's a simpler one. This reduces down to, from the previous formula, if we use n da 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 da, and we replace all of these here, then that gives us this, which is a lot nicer to look at. And this is called the binomial theorem, which is like a subset of the binomial expansion, which only works for positive integers. So what it does is, that's your NCR right there. The best way to show you how it works is just show you in action. So we're calling this X and we're calling this Y. That's confusing. So let's call it A and B instead. So this is B, this is X. So now the question wants us to find the first three terms in the expansion in ascending powers of X. This is a key term you need to know. Ascending powers of X means you start at the lowest power of X, which in this case actually X to the power 0, which is a term without X. And then you go up to the next term with X to the power 1, X squared, and you show it in this order. So I'll write it in order. First one, right, let's use the formula here. 7 is up here, so n is 7. So now let's write it down. 7 C0
But you have to also
times,
kind of look at that the negative 3x is b in this sense. So won't it
uh,
be like in the other way around when you were trying to find it in the ascending powers of x? Because like
well,
if we
it's,
look at this, right, it says in the binomial expansion at the end, it says nn
uh-huh.
and combination n times x0 times y to the power n. So here essentially, oh wait, it's
Oh,
ascending powers of n. Okay, wait, never mind, my bad, my bad. That makes
oh,
sense. Yeah. Because
okay.
initially it's going to be x to the power 0.
Yeah. So initially we have 1/2 to the power 7, and then minus 3x to the power 0, which is just, 1. And just the first three terms. So 7c1, and then we reduce the power of x by 1. We go down to 6, and we throw on minus 3x. And then we're going to do one more, because it says three terms. 7c2. Personally, I would write it like 7c2, because I don't like this form. But I'll just follow the thing here. Which
It
one do you
also
prefer?
actually takes a lot of space. It takes a lot of space to write it like in the brackets, like in a vector-ish way.
Yeah, it does. Half to the power 5 and minus 3x squared. Right. Now, if I hope you guys remember how to use that calculator thing, you just type 7c0, which is 1. This is 1. 7c1 is 7. 7c2 is 21. Yep. And now we can simplify this. So it's 1 times half to the power 7. I put half here intentionally, not as an awkward number to use, because sometimes you do get questions like these. Right, so this simplifies down to 1. This simplifies to 1 over 128. I'll write this up here because there's another little section down here. 128, and in a different color, honestly. Blue, no, green. 1 over 128. And sign here, remember, this is positive, but this is negative because that's minus 3. So I'm going to put a minus sign, and I'm going to put, so this is 7, this is minus 3, this is 1 over 64. No, yeah, 64. That simplifies to 7 times 3 times 64. So minus 21 over 64x. Right. Next term. This is 21. This is 1 over 64. 1 over 32. And this is positive because it's the squared. So 9x squared. Multiply these. 21 times 9 divided by 32 and plus 189 over 32 x squared. These are our first three terms of the expansion. Oh, okay. Right, so that's how we do binomial expansion. We just use this formula. If we wanted to write it out all the way, we would just end up to the point where x equals x to the power 0. So just like think about it in terms of Pascal's triangle. That's a good way to do it. Okay, so questions, usually they have some sort of twist to them. And here are two types of twists that you commonly encounter. The first is a negative power of x. And as you know, minus x is not a negative power of x. Power here is 1. The negative power of x means it's on the bottom of a fraction, because this is same as x to the power minus 1. So using this knowledge, we can write this as 2 minus 3x to the power minus 1 to the power 4. And and this question says descending power of x. So you might think, oh, I'm going to start with x to the power minus 4 first, because that's how powers work. But this is the lowest power of x, and it should be placed last. What they want us to do is put the constant term first, because a constant term has x to the power 0, which is greater power than x to the power minus 4. Right. That's a lot of fluffy language, so let's just put that to use. Should I use the C something? Yeah, just for an example, I will. So let's start it. There's 4 things. Wait, it's 4C0. I'm gonna write it different form now. 4C0 times 2 to the power 4 times 1. Because I'm not gonna write this to the power 0. That's just 1. I'll only do the first 3 terms to get you guys the idea. 4C1 times 2 to the power 3 times minus 3 to the power minus 1 plus 4C2 times 2 to the power 2. Yeah, that's right. Times minus 3x to the power minus 1. You need to be really focused when you're doing this stuff, because a single minus sign, positive sign, single missed term will give you a vastly different answer.
I
Okay.
think this is actually one of the topics where I found the most difficulties, especially because if you make one small mistake, you would see it at the end and you realize how silly the mistake would be. Because there's a lot of
Exactly.
working out necessary for these kind of questions.
Right, so this is 16 plus, actually minus, because as you can see, that's a minus sign there. This is plus. So minus 3 times 2 to the power 8 times 4C1, which is 4. So 8. Okay. 4 times 8 times minus 3 minus 96 x to the power minus 1. Okay, I'll add one more thing at the end here. 4C2. 4C2 is 6, and this times 2 squared times 9. And this is positive 9 because minus 3 squared positive. So 6 times 9 times 2 square is 216 x to the power minus 2. Right? So of course there's a few more terms here, but I'm stopping there. In your final answer, you can leave it at this, but I would suggest, because Cambridge generally does not like negative indices. So, I mean, it's not a big deal, but just for neatness, I write 6 over x plus 216 over x squared, like that. Okay, here. Right, so another way that this binomial expansion can be made a bit more confusing is by putting in another expression to multiply your expansion. So first, the way you do this, I want the first, let's work with 3 here. First 3 terms in ascending power of x. And the first, I would expand this, and then I would multiply it by the expression. So I already have the expansion prepared. You can practice this on your own if you wish, but the expansion is 15,625 plus 37500 x plus 37500 x squared. And you could go on, but you don't have to in this case because you're only interested in the first 3 terms, which in ascending power of x. So that means constant term, x power 1, and x power 2. X power 3 is not a term that we want here. And thinking about it, if we multiply this by x plus 2, x minus 2, multiplying by the constant will keep the powers the same. Multiplying by the variable of power x power 1 will only increase the powers by 1, which means we still have our x squared terms. So since I am interested in all 3 terms, I will do it fully. So what I'm going to do first is multiply everything by 2, minus 2. This will give me 5 to the power 6 times minus 2 minus 250 minus 7500 x, 75,000 x minus 75,000 x squared. And now I'd multiply everything by x. So I'll actually shift it a bit to the right. So since when we multiply by x, this becomes 15,625x. And then this term becomes 15,625x, as you can see, because we multiplied by x. And this term becomes 37,500x squared plus 37,500x squared. And when we multiply this by x, it actually goes to x cubed, which is out of our bounds. We only want the first 3 terms. So now we total these up. By totaling these up, we get minus 31,250 constant term, and then 75,625 minus 59375x, and then minus again. What's the difference? What's this term? Collecting these like terms, we get 75,000 plus. Oh, awesome. It's just half of that. 37,500 x squared. So these are our first 3 terms in expansion of this. So remember the thing? First expand it and then multiply it by the expression outside. Okay, that's the 2 ways, right? So here's some language things that they will ask you. Give the value of the term independent of x. What this means is the term without x in it, a constant term. So our term independent of x is minus 31,250. Remember the minus sign. Okay, another thing they might ask you is give the value of the coefficient of x cubed. We haven't done x cubed in this case, so I'm just going to ask you x squared. The value of the coefficient of x squared is a thing multiplying x squared. So it's that right there. minus 37,500. Okay, so those are just types of questions they might ask you. Now we have a couple of questions here. Not too many, mind. Yomesh, would you be willing to help us with the first one?
Sure. So we just use the binomial theorem, right? So it'll be 1 to the power. Actually, technically, we could just do it straight away. We don't even need the binomial theorem for this.
Yeah.
Yeah, so we could just do, it's going to be 1 minus 1, 2 times 1 times negative 1 upon 2x.
Negative 1 upon 2x.
It's going to be a plus in the 1 plus in the left.
All right.
And then it's just going to be plus 1 upon negative 1 upon 2x squared. And so when we expand this, it's just going to turn into 1 minus 1 upon x
Mm-hmm.
plus 1 upon 4x squared.
Nice. You want to do the next one as well? Oh, wow, this is a big question.
Yeah, sure. It says find the first 4 terms in the expansion in ascending orders of x of this. Okay, in this case, we need to use the binomial theorem. So I'm just going to go with 6c0 times 1 times 1. Add that with 6c1 times 1. The thing is, the reason why I'm saying 1 is because 1 to the power 5, 1 to the power 6, it doesn't really matter. So I'm just going to keep it as it, but you could also put a 1 upon 1 to the power 6.
Mm-hmm.
And the next one is going to be times 2x. And it's going to be 6. It says 4 terms, so 6c2 times 1 times 2 to the power x squared as a whole, remember? And then it's going to be plus 6c3 times 1 times 2x to the power cube. And so when we simplify this, c60 is going to be 1. C61 is going to be 6 times 1 times 2, so that's going to be 12x. 6c2, I don't have a calculator with me, so can you calculate that?
6c2 is 15 times 4.
So that's going to be 60x squared. And then lastly, it's going to be c63 is, I think,
20.
Actually, 20. Oh, okay. 20 times 1 times 8. That is going to be equal to 160.
160 x cubed.
Cube. Yeah.
Yes. Okay, so that's our expansion there. And hence find the coefficient of x. Okay, can I do this and I want to show something?
Yeah, sure.
So it says coefficient of x only. So that means we don't need to worry about the other terms. It's just 2 marks, guys. Tests your timed. You don't want to do the whole expansion here just because they asked you what's the value of x. So what you're going to do is look over here. Find, so this one's a constant term. This one's a x minus 1 term. This one's a x minus 2 term. And here you've got a constant term, x power 1 term, x power 2 term. So thinking about the powers, how many ways can we make x? One, we can multiply a x power 0 by x power 1. Or we can multiply an x power 1 by a x power x power, wait. Oh, 0, that doesn't mind. That doesn't matter. Or we can multiply an x power 2 times an x power minus 1. Or we could even multiply an x power 3 times an x power minus 2. And that these would all give us values of x, terms with x. So in this situation, what I'm going to do is I'm going to multiply first the constant. Okay, so there's no x powers 2 up here. There's only x power 2's down here. So I'm going to multiply first x power 2 times constant. Wait, no. First, I'm gonna wait. First, we want x, so we're gonna first multiply x times the constant term. So 12x. Change color here. Now I'm gonna multiply x squared times x power minus 1, which still gives me an x. So what's minus 1 x power 1? So it's 1/4 x power. So 60 times minus 1 is minus 60 x. There's still x, yeah. And then I'm going to look at 660 x power 3 times x power minus 2, which gives us x power 1. And the coefficient of x squared here is 1/4. So 1/4 times 160 is 40. And it's a positive sign, plus 40x. So when we total these together, 12 minus 60, 12 minus 60 plus 40, we end up with minus 8. So the answer is minus 8 is the coefficient of x. You can just give the answer as minus 8. You can give minus 8x. Doesn't matter. So let's check the answer. Yes, indeed. We got this. We got this. And make sure you show you're working. Because if you get a little mistake somewhere, they'll still give you marks. So you get products from each thing and you total them together. Awesome. Let's do another quick one. Given that this. Find the possible
Should I do
value.
this question?
Sure, go ahead.
So it says that the first three terms in ascending order of x for the expansion of 1 plus ax to the power 6. In this case, we're going to use the binomial theorem again. So it's just going to be 6c0 times 1 to the power 6 times 1 ax
Yeah, that's
to the
just
power
one.
0. Yeah, you could just say that. Plus 6c1 times 1 to the power 5 times ax to the power 1. As you can see here, as the power of 1 decreases, the power of ax increases. And we're going to do plus 6c2 times 1 to the power 4 times ax squared. And boom, we have our three terms. Now we just need to simplify it. So the first one is just going to be 1 plus 6 times ax. So it's going to be 6ax. And then it's going to be 6/2 is, I think, 12, or was it 20?
15.
15. Oh, yeah, 15. We just did this. So 15 times a square, x square. Remember, it's a whole square, so you have to ensure that you do a square, x square.
Okay. Given that the coefficient of x squared in the expansion of is minus 3, find, oh lord. Okay. Start off with finding the coefficients of x squared, just in terms of these expressions. So we've done this expansion. We're going to now multiply it by this expression to get our terms. And again, we're only looking for x squared. So let's see where it makes x squared. Well, one constant term times 15a squared x squared makes x squared. And minus 3x times plus 6ax also makes x squared. So I'm just going to include those two terms. So I'm going to do 15a squared x squared times 1, which is the same thing. And then I have 6ax times minus 3x, which gives me minus 18x. My mental math is off the charts right now. Yes, there we go. 18ax squared. And this is 15a squared x squared. So we total these, and that gives us 3. So what this tells us is 15a squared ignoring these, because we're just looking at the coefficient part. Coef, yeah. And 15a squared minus 18a. Just pretend we factorized it. I took out the x squared, yeah. This equals minus 3. That's what it means. And when you look at that, it's in the form of a quadratic equation. You could even reduce it down a bit. You could say 5a squared minus 6a is minus 1. And then you could just bring everything to one side, make it equal 0, plus 1, 6a, 5a squared. Put it in your calculator, quadratic solver, 5 minus 6, 1. And you end up with x minus 1, 5x minus 1 is 0. So your values of, well, they're a, by the way. They're a, not x. So your values of a are, I keep writing x, just out of habit. A is 1 and a is 1 by 5. So those are two values of a. If you check this, yes, indeed, that's how you do it. You have to show that you multiplied some terms together, like the coefficient 3a to get x. Make it equal to 3, solve it quadratically, show your answers. Easy 4 marks. Okay. Okay, Vyomesh, would you like to help us through this one?
Sure. So it says the coefficient of a to the power 4 and the expansion of this is a x to the power 4. The coefficient of x squared and the expansion of this is b. Find a and b in terms of constant k. Okay, I think it's pretty easy. So to find the coefficient of x squared. Oh wait, never mind. It's not easy anymore. I just realized.
Oh, wow.
Oh, I see what they're trying to do. It's a very
It's the mean.
confusing question indeed.
Mhm.
But what I would say is this. Okay, this is what I would visualize it as. I would first of all look at the exponents of each, right? For example, the first term, right? It's going to be x to the power 10, right?
Where are we?
Because it would be 2x
This one?
squared to the power 5. Yeah, for the first expansion, right? I'm
Oh,
going to
yeah,
try to
yeah, okay.
imagine what it is. So for the first one, it's going to be 10, right? Because 2 times 5 equals to 10. Then the next one, it's going to be 2x squared to the power 4, and then times 1 upon x, right? So the second term, it's going to be x to the power 8 minus 1, which is x to the power 7.
Mm-hmm.
And then the third term, it's going to be x to the power 6 times 1 upon x squared.
Oh,
Oh, yeah, sorry. I just kind of disconnected.
hello?
So for the third term, it's going to be x to the power 6
It's all
divided
this.
by x squared.
Okay, the Wi-Fi just cut out for a sec.
Yeah,
Okay.
it's going to be x squared there. Underneath x squared. Like 1 upon x squared. Yeah, that's
Oh,
good. That's
you
good.
mean like,
Oh, I think we found something, didn't we? The third term, it's basically x to the power 6 minus x to the power 2. So that's going to be x to the power 4, right?
Mhm.
So what we found is that the third term of this expansion is going to give you x to the power 4, right?
Mm.
Okay, now we take that and now let's actually look at the values. And instead of just looking at the exponent, let's calculate the term, okay? So it's going to be, for the third term, right? It's going to be 5c2 because we're trying to find the third term, right? So it's 0, 1, 2. That's the third term. Then it's going to be times 2x squared to the power 3. And then times that by 1 k squared upon x to the power 2. Also, by the way, an interesting thing, I just wanted to point it out that look at the exponents of both of these, 3 and 2. They always add up to 5. They would add up to the exponent of the original expansion, always. So if one increases, the other decreases, right? So it's going to add up to 5, the exponent originally. And when we actually expand this thing, right? What is 5c2? That's 10, right? 10 times 8 times k squared. Let's try to expand this.
Okay.
So
5c2
yeah.
is... Wait, I'm on quadratic mode. 5c2 is 10.
And then times that by
Times
8. And then times that
times
by
8.
k to the power 4.
It's k to the power 4. So
And then that'll
80
be 80
k to the
to the
power
power 4 x to the power 4.
4.
So now we have found A, right? Now we need to find B like this, using the same
Yes.
idea. Okay. This B version would be much easier because there's no weird x's
On 2
underneath in
x's.
the denominator.
Yeah.
Yeah. And so in the expansion for x squared, we kind of already know what's going to be. Then the first term is going to be x to the power 4, right? The second term is going to be x to the power 3. The third term is going to be x to the power 2. And boom, that's it. It's going to be the third term that's going to be x to the power 2.
Wait, oh, right. I didn't read the question. I was thinking x to the power 4 in both. Right. Pro tip, guys, read the question.
It says x to the power 2, so it's just going to be like 4, 3, 2, so the third term. So for the third term, it's just going to be 4c2 times 2kx to the power 2
times minus 1.
Yeah, minus 1 to the power 2. Yeah. So when we expand that, 4c2 is 8.
Is 6.
Oh, it's 6. It's 6, yeah. 6 times 4.
4.
So that's going to be 24k squared x squared.
Okay. This is B. This part is B. 24k squared is B. Awesome.
I think that should be it.
And yes, 80k power 4. Ta-da. See, when you have two x's, two separate x's in your expansion, you have to, like Vyomesh did, you have to look carefully to see which one makes the one you want. Okay. Right, so now we're done with binomial. We are now moving on to sequences, which is thankfully... Okay, it's not a difficult topic. I'll give you that. There's like 3 formulas you need to know, and once you know, you can do it. But it's just the questions are suspiciously similar to word questions. Like they'll give you a word problem, and you need to piece together an equation from that. Okay, so we'll get to that later. Let's start with a recap of what we know. A sequence is simply an ordered set of numbers where there's a clear rule to find the next number. That's textbook definition. Here are some sequences. What's the rule? Write down the next term and find the rule. For this, I can see that, yes, these look like odd numbers, don't they? There's a +2, +2, +2, +2. I would think the next one's 11. And the rule is you add 2. So this is a bit of pattern finding. Okay, these numbers, they look like square numbers. So next one is probably going to be 36. And they're square numbers. This one, it looks like they're doubling, but the sign is flipping back and forth. So I know that times 2, but since the sign went minus, I'm going to times -2. So I think the next one is -64. it's times minus 2 each time. Times. So these are some kinds of sequences, just to get the idea across. Now let's look at some formal sequence terms. You're probably familiar with the nth term thing. It's what describes a sequence. In AS level, we use these formulas. UN means the nth term. It's a general formula that describes all the terms. You could U1 means first term because it's just n is 1. And then UN plus 1 actually means n plus 1th term, which means the next term after this one. So we're on n, and n plus 1 is the next one after n. Okay. So here's a question. What is the nth term of these sequences? For the first one, I can see it's simply 1, and then, no, let's do, we add 2 each time, plus 2n, and then we subtract 1 for the first one. The second one is simply n squared, because each term, oh, by the way, we start at the first term, u1, so first term's 1, da da da. This should be recap. 2, and then we multiply it. We're multiplying it by 2 each time, so we're doing 2 to the power n minus 2 to the power n. But then the first term is actually 2. So the way we do this is 2 to the minus. We'll see this in geometric progressions. First term, ratio, da. Okay, and find the 8th term for the previous sequences. What we do is we just, instead of n, we put 8. So 2 times 8, 16 minus 1. That should be 15. For 8 squared, that should be 64. For this, I'm going to use my calculator. 2 times minus 2 to the power 8 minus 1 should be minus 256. So this is a recap of sequences. Maybe you might not have done geometric, but you've definitely done linear, algebraic, arithmetic, that's the word, linear sequences, and maybe quadratic. So we're just going to cover a new thing here. It's called sigma notation and series. A series is just when you take a sequence and you add the terms together. That's all it is. Like you have 1, 2, 3, 4. That's my sequence, which is simply n. Each sequence is n. And when I add these together, I get a series. And the way I show that I've added them together is called sigma notation. So what I've done is I've added together, sigma means the sum of, we've added together n, and if I want to do the first two, I've started from n equals 1, and I go up to 4. So 1, 2, 3, 4. Let's look at this example they've given here. This is a series. If we had commas there to be a sequence, but since they're being added together, it's a series. And the general term is r, 4r plus 1. They're using r here instead of n. And yeah, that depends, but it's just a variable. It's the number of the term. And when we're adding together a finite number of terms in a sequence, we write it like that. We read this as the sum of the series divided by the sequence 4r plus 1, and then we start at 1. So it's like a count. If you're familiar with computer science, it's like a counter, and you increment it by that much each time. It's like you start r at 1, and then it goes to 2, and it goes to 3, and it goes to 4 until it reaches 6. So each time it increases by 1, and we get, so first one where r is 1 is here. Second term, r is 2 is here. R is 3, r is 4, r is 5, and the sigma means we add them all together. You don't need to know this that well. It's just a little thing that you get on the side. When you're doing series later on in maths, this comes up a bunch. So you can also write for an infinite series by starting at 1, goes up to infinity. So thing on the top of the sigma is infinity. Right. So that's all that you would actually need to know. Oh. And here's an extension little thing I have here. Find the value of this expression, which means it's the 1, 2, 3, 4, 5, 6 things added together, which gives me 5 plus 9, 5 plus 9 plus 13 plus 17 plus 21 plus 25. This gives me, oh, I missed a term there. 17, 90. The value of this expression is 90. Okay, so this isn't too, that wasn't too important to our syllabus, but this definitely is. I'm going to turn on a light real quick. Okay. So I was saying the previous page wasn't too important to your syllabus, but this is the main chunk of this topic, arithmetic progression, and then the other one is geometry. We're going to do arithmetic first. Arithmetic means common difference. That should be deep rooted in your head by the end of this. When there's a common difference, we use arithmetic. That means each term increases by certain. Let's say we have 1, 3, 5, 7, 9, just like before. And the common difference between them increases by 2, plus 2, plus 2, plus 2. This is an example of an arithmetic sequence. And the notation we use for these, the first term is defined as A, the common difference is defined as D. These aren't just arbitrary letters. I really do suggest you use the letters they give you here. A as first term, D as common difference. And the nth term, when you write it this way, is the first term plus the term number minus 1 times D. So for the first term, where n is 1, you just do 1 minus 1 times D, so that's 0D. So the first term is A. That's where this A comes from. Second term is when n equals 2, 2 minus 1, D, and D. So that's how the terms can be written. This will be important later on, when they'll give you a certain term and you will have to construct an equation for it. These in terms of these variables. That's a minus 1, by the way. Okay, so here's a little bit of practice. Let's construct some expressions for the nth term. We know the common difference here looks like it is 3 plus 3, by the way. Make sure you keep your signs there. Plus 3. So D is 3 plus 3, and first term is A. First term is 1. So I know my expression is 1 plus n minus 1. Common difference is 3. This is my expression for this arithmetic sequence. We can do the same thing here. It goes minus 4, minus 4, minus 4. D is minus 4, A is 11. So it's 11 plus n minus 1 minus 4 is equal to the nth term. Nth term. Okay, that's all for the progression. Now, the important part of this topic is when you sum together the series. Remember we added up a bunch of things and called it a series? That's what we're doing now. So first you got to remember the A and D. Those are the two important variables that we will be looking for, as well as the sum and the nth term, which is expressed in terms of those. Okay, so the main thing here you need to know is sum of arithmetic progression. Formula here is given. L here represents simply the nth term. The last term in the sequence is the nth term. So if we're adding up, S means sum of. So sum of all the terms up till the 30th term. Well, our last term would simply be the nth term, which is here the 30th term is the last term. Okay, that makes a little bit of sense. Sn means we're adding n terms of the arithmetic progression together. It's a series. So I'm going to write here in sigma notation. What it means is Sn means from, we always start at 1, by the way, from n to 1 up to, that's not helpful, this n. So let's say it was up to 30, it'd be up to 30. And then our arithmetic progression formula, like a plus n minus 1 d. That's not a real big thing, but I'm going to prove to you how this formula comes about. Sn simply means we're adding together all the terms. Remember, first term was a, second term was a, and yeah, that's the nth term, n minus 1. So second term is a equals 2, so that's a plus d plus a plus 2d plus a plus 3d, and this all the way goes up till L. This is up to L. And the term before L is where n is minus 1. So 1. Wait, what's my screen doing? Right. So this goes all the way up to L. And if we write it backwards, right, so L is the last term. And if you want the term before L, remember each term we add d to get to the next term. If we want to go backwards, so we want to subtract d. So L minus d is my previous term. I have L minus 2d. See, the common difference is the same. So this is just a general thing. Now if I write it backwards, L plus L minus d plus L minus 2d. By the way, the proof is not necessary for the syllabus. It's just to help you understand how it comes around. A plus d, a plus 2d. So what you'll notice is like this. If you do it like this, the d's cancel each other out. And I've intentionally done it like this. Sn is this. Now let's add these two together to get 2Sn. And then what we've just done is we have a plus L here, a plus L here, and again we have a plus L here. And this continues all the way through. We just have a bunch of lots of a plus L. And in fact, since there were n terms in the sequence, we have n lots of this. So the way I can write it, I'll clear this for a second.
I actually never thought about this proof. It's quite interesting to see.
Oh my goodness. There's, when you're working with stuff like this, you can prove things prove false things, because when you start working with infinite sequences and stuff, the rules get a bit wacky. But okay, so we were at 2Sn equals, there were n lots of a plus L. That's because we did all those a plus l thingies. And now Sn is simply divide both sides by 2, n minus 2 a plus l. And remember, L was our last term, which is just the nth term, which is that. Okay, that's where the formula comes from. You don't need to know how to derive it. You just need to know how to use it. So let's use it a few times, right? That's just a hint. Question: find the sum of all the odd numbers between 20 and 100. Find the nth term of this arithmetic progression. Right. So I'm going to start with the nth term first, because between 20 and 100 we have the first odd number that comes in is 21. So 21 is my first term, so that's a. 21 is a. My common difference for between odd numbers is obviously 2, so d is 2. And then now I can construct my nth term equation. Un is first term plus n minus 1, common difference, so un is 21 plus n minus 1, 2. So that's my nth term. And now I want to find the sum of these numbers, sum of this sequence up to what point? That's the question. So 99 is the last term in this sequence. And we can use a method to calculate this. If we put 99 as the nth term, then we can find n by 21 plus n minus 1, 2. And that just, if I'm going to skip the math here, 99 minus 21 divided by 2, and then we add 1, so 40th term. So n is 40 here. But I just used algebra to get that. Okay, n is 40. So I want to add up all the terms starting in this sequence. In this sequence, no, the bottom one. In this sequence, I want to add up terms going from 1 to 40. So it's a sum up to the 40th term. And now I'm going to use my equation. N is equal to 40. That's the last term. I'm going to do 40 divided by 2 here. I'm going to show you this method first, and then I'll show you the shortcut method. 40 over 2. And then I'm going to do 2 times the first term, 2 times 21 plus n minus 1, 40 minus 1 times 2. And if I simplify this, it's going to be 20 times 42 plus 39 times 2 times 120. 20 times 120. It should be equal to 2,400. So that's one way of doing it, 2,400. The other way to do it is, since we know that sum of the arithmetic sequence is simply the number of terms divided by 2 times the first term and the last term. Our first term was 21. Our last term was 99. And we had 40 terms. So this gives us 20 times 21 times 92, which is again going to be 120. So again, 2,400. That's another way of doing it. So that is, make sure you know what Sn means. It means the sum of all the odd numbers between 20 to 40 in the sequence defined by this, with n going up to 40. Okay, there's more questions like that later, but now let's move on to geometric progressions. Where arithmetic was a common difference, a geometric has a common ratio. This is important. So again, we use the similar terminology. A is the first term, but here instead of D we use R because it's a common ratio. And we write it as the first term as A, second term as AR, ratio. So the nth term we write it as UN is first term times the ratio to the power n minus 1. Okay, it's just, again, because ratio between this to this is r, this to this is r, this to this is r, like that. Let's look at these geometric progressions and write some expressions. So here I know that first term a is 3, and when I divide 6 divided by 3, I get, you want to divide the second term by the first term always, not the other way around. So 6 divided by 3 is 2. Again, you can just tell that it's doubling, can't you? So r is 2 plus 2. So my un is 3 times 2 to the power n minus 1. Okay, let's do this one. Let's do minus 12 divided by 24. Minus 12, oh, obviously, it is minus a half. So this is our common ratio. It's going down, it's multiplying by minus 1/2 each time, as you can see. And our first term is 24. So our nth term is first term, 24, times minus 1/2 to the power n minus 1. Okay. Nicely done. Now let's look at the sum of a geometric progression. This is a little bit more interesting in that the formula looks a bit scary at first. But once you understand why we use it, it's not a big issue. Okay, so what's going on in this formula? Sum of the first n terms in the geometric progression is equal to a, the first term, times 1 minus r to the power n, the ratio to the power n. And this is valid only if magnitude of r is less than 1. So it can be like minus 0.9999 or plus 0.999, and you'd still use this formula. But if it's not, then we have a different formula. Common ratios more than 1 or less than minus 1. We multiply top and bottom of this formula by minus 1, and that gives us this new formula, which is valid for that range. So I will use this here to write the proof. Right, so sum of the things is first term a plus 8 times r plus 8 times r times r. So r square, so 8 times r3, and so on until we reach a to the power n, no, r to the power n minus 1. So you multiply everything by r. This is rsn is ar or. Okay. So on, so forth. And they'll be r4, by the way. And that means the last term is no longer n minus 1, it's rn. And now we are going to do something quite funky. We're going to say, we're going to take this. Okay, we're going to take this sequence and we're going to subtract it from this sequence. Watch what happens. Sn minus r. Yeah, Sn. So this, from this, we're subtracting the lower one. So these cut out, these cut out, these cut out, and even we do have a to the power n minus 1 in here somewhere. So these do indeed cut out, and we're left with a minus 8 because we're subtracting this a to the power n, and we can actually factorize out a from this a to the power 1 minus r to the power n, And what do we do next? We can factorize this side as well. Would you look at that? We factorize out Sn 1 minus r. It's really clever. I didn't know how to do this. I just looked at the textbook. 1 minus r to the power n. And then to get Sn by itself, we divide both sides by this, which gives us Sn is equal to a1 minus rn over 1 minus r. And if we want the other type of formula, we just give times minus 1 times minus 1, gives us plus, minus, minus, plus. And that's the other form of this formula, as shown here. Right, so that's the two forms of the formula. Awesome. Now let's move on to some questions. How to use this formula? Well, we're given here in a nice form, 8 times r to the power n. That should be r to the power n minus 1 form. And we just need to, wait, what? Go back. We just need to find the form. We just need to find the GP sum, right? So we want sum of the first 4 terms, S4, is equal to, first term is 3, and wait a second, the common ratio is more than 1, so I'm going to use this form of the formula. Sum to the power 4 is 3 times 2 to the power 4 minus 1 over 2 minus 1. And this gives us, when you're typing this in your calculator, make sure you keep the fractions untouched. 2 minus 1, 45. Seems reasonable, yes. And here we have similar thing, but we can see the common ratio r is less than magnitude 1 here. So I'm going to use the top formula, not the bottom one. So a is 50, r is 1/2. I'm going to use sum to the first 4 terms is 50 times 1 minus half to the power 4 divided by 1 minus half. This will give me 50 times 1/4 to the power 4, 1 minus 1/2. This will give me a hideous number that looks like this. 64, which is somewhere around 99.61 approximately. Right, so that's the sum of the first 4 terms in this sequence. Okay, awesome. And there's one more thing about geometric progressions. If you have your common ratio is less than 1 in magnitude, so it's something like 0.5 or 0.9 or even minus 0.9. Well, over time, as we multiply this by itself, it's going to get smaller. Because, 0.9 times 0.9 becomes 0.81, and 0.9 again becomes 0.73, and it gets down and down and down. So the concept here is, since we want n to reach infinity, the thing is, as n is approaching infinity, r to the power n, which is, remember, r is smaller than 1 in magnitude, is approaching 0. Because there's, 0.5 to the power n. Will this ever reach infinity? No, but I mean, neither will. And infinity isn't like a point to be reached. It's just, it means you keep going, keep going, keep going. And as you increase this power hugely, 0.5 to the power n will decrease vastly. So at infinity, which is a point we just kind of define as keep going, eventually, in theory, it will reach 0 as n tends towards infinity, r to the power n gets smaller and smaller, tends towards 0. Okay, that's the idea. And this gives us this formula because a to the power 1 minus r to the power n over 1 minus r, this thing here tends towards 0. So we can substitute in 0 for it, a 1 minus 0, 1 minus r. So that's gone. So we just have a over 1 minus r. Awesome. That's what the formula. You do more stuff like this in limits and calculus and whatnot, but that's all you need to know. One more thing, sum to infinity only works if the terms get smaller. If, let's say, we had an arithmetic sequence, 1 plus 2 plus 3 plus 4, the terms are getting bigger. They're not converging. The word for this is convergence, that it approaches a set value, that it doesn't just infinitely increase. It slows down the increase until it, in theory, reaches a point. That's the word convergence. You can search up some videos on those. It's a fun topic. But for now, you just need to know this only works if the ratio is less than 1 in magnitude. That means it's converging. Okay, so here we have questions. Find the sum to infinity. This is easy. A is 3, so 3. And R is 4 by 5. So 1 minus 4 by 5. Our sum to infinity will be 3 over 1 minus 4 by 5, which is simply 15. Isn't that nice? Okay, now let's do 18. Next one, 18 is our A. Common ratio is minus 1 by 2, so we need to put that in brackets. So 18 over 1.5 is 12. That's what it tends towards. Sum infinity of that sequence there. Awesome. Okay, so that's the topics covered, in theory at least. You will see that in questions, you will need to think quite hard about the words that they give you. Because they won't just give you formula here, work it out. You'll need to produce the formula from the words given. So Vyamish, please help us here. What shall we do?
Can you try on the first question?
Sorry, should I do this one?
Yeah.
Yeah, okay. The first, okay, so this is the word question. They've given you some hints. Second term is this, third term is this, respectively. So the first thing we need to use is our concept of how geometric progression is written. Remember, it's un a to the power r n minus 1. So our second term is a to the power r, and n is 2. So I'm just going to write 1. And this is equal to 10. And our third term, u3, is a to the power r square, and this is equal to 8. So I think you have the idea already. We can get the common ratio by doing this. If we do u3 over u2, this is same as doing ar square over ar, which is same as doing 10 over 8. And look at this. This is the a and a cancel, the r and r square cancel, so r is equal to 10 by 8. So we know the third term is this, second term is this. What's the common ratio between them? That's all we're doing. So 10 by 8, 10 by 8, same as 5 by 4. So that's our common ratio. Wait, no, it doesn't. We've flipped it wrong way around. U2 is 10, so it should be at the bottom. U3 is 8, should be at the top. It's always second term or next term over previous term. So 8 over 10. So yeah, 0.8 is our common ratio, 8 by 10. The way I got that hint is it says sum to infinity, and somehow I got something. I got r, which was more than 1, so I knew immediately that was wrong. So backtracked. Okay, so that's our common ratio. That's only one of the things we need for a common sum to infinity formula. So I need to find r now. I found r. I need to find a. So I can put this in any formula. A to the power 0.8 equals to 10. So I know that a must equal 10 by 0.8, which equals 12.5. So now I know the value of a, I know the value of r. I can put this in my sum to infinity formula, which is in the formula booklet, by the way, but I just suggest you remember it. 0.8. This gives us over 2. 62.25. No, not 25, 62.5. That is our final answer. So in questions like these, the idea is from the information given, second term is this. So you write down your formula. Third term is this. You write down your formula. And then by using those formulas, you can find the common ratio, or at least an expression for the common ratio. Like that, we got a nice value here. And once you have that, you can also find a, and you can get ready for your equation. So here we have it. 1 mark for ratio, 1 mark for a, 1 mark for showing the formula, and 1 mark for your correct answer. Okay, are you ready to do the next question, Vyomesh?
Sure, yeah. So looking at this question, it says that the 13th term of an arithmetic progression is 12, and the sum of the first term is, and sum of the first 30 terms is negative 15. Find the sum of the first 50 terms of the progression, right? So it says that the 13th term of the arithmetic progression is 12. Okay, so let's make an equation out of that. So u30, u
13.
Oh, it's the 13th. Okay, 13th. So
Yeah.
U13 equals to A plus 13 minus 1D.
Yeah. 13 minus 1.
So you could just say 12D,
Yeah.
right? And then let's just get all of the equations out of the way. So it says that the sum of the first 30 terms is negative 15. So looking at the formula for arithmetic series, what we have the sum of 30, right? And then, so it's just going to be, let's see, and n here is 30, right?
Yeah.
So it's just going to be 30 upon 2 times 2a plus 29d.
All
Just
right, we have
30.
n.
Yeah, we have n here.
So n minus 1, 29.
29d.
D.
So I'll just create two simultaneous equations. So let's simplify the S30 equation first. So it's just going to be 30a plus, let's see. Can you calculate that calculation?
Okay, 15 by 29. 435.
D equals to negative 15.
Minus 15.
And so I will take the first equation that we found and multiply it by, let's say, 30. So it's going to be 30a plus 360d
30a plus 60d equal to
equals
12 times
to 360.
360.
And now I'm just going to subtract both of the equations to cancel out a. And I'm going to get 40, 75. The 75d equals to, let's see, negative 375.
Yeah.
And so what I'm going to get for d is just divide 75 on both sides.
Wait. D is equal to minus 5.
Yeah. And now that we have D, I mean, the end goal is basically to find the sum of the first 50 terms, right? So we need to find D and A both. So let's take it into any of the equations, right? So let's say 12 equals to A plus 12D. So let's just take it into that. So 12 equals to A plus, minus 60.
Oh yeah,
It'll
minus
be minus
60.
60. Yeah. And so A would be equal to 72. So
Yes.
now with these two values, we could just find S30. So S50. So it's going to be 50 upon 2 times 2A, which is 144.
Okay.
And then plus that by 49 times D, which is negative 5.
So 25 times 144 plus 49 times minus 5. Okay. Minus 101 times 25. Yeah, seems about minus 2525. S50 is equal to that. And remember the formula we used was Sn is and by 2a plus n plus n minus 1 times d. Yeah. So that's our final answer. Okay, thank you very much. Let's see. Indeed, 1 mark for identifying the 13th term, 1 mark for identifying the sum to 30, 1 mark for finding both A and D, 1 mark for showing putting in the formula, and 1 mark for the answer. I'll say them. I will do this one. The second term of a geometric progression is 54. Just first thing I see the information, I'm gonna write something. U2 second term of a geometric progression is 54, which means since AR n minus 1, AR is 54. And the sum to infinity is 243. So S infinity is equal to A over 1 minus R, which is equal to 243. The common ratio is more than 1/2. They probably specify this because there's 2 possible answers. So I will keep that in mind. And our goal is to find the 10th term. Okay, so let's first find A and R. We have these two equations. What I would do is multiply every substitute. Yeah, get R by itself for basically. Or yeah, I'd get A here. So 54 divided by R is equal to A. That's my one equation. And here I would rearrange it so that A is equal to, I'd multiply both sides by 1 by R. So 243 minus 243R. Just open the brackets. And now, since I've rearranged both things for A, I can just make it equal. So 54 by R is equal to 243 minus 243R. So what I'm seeing is that these look like a quadratic. Yes, I could multiply everything by R to get 54 is equal to 243R minus 243R squared. Since now we got rid of the weird fractional. And now we can move everything to one side. Minus 54 equals 0. Now we can use our quadratic formula where this is A, this is B, this is C. A is minus 243. B is plus 243. And C is 54. What? I don't think that's right. Can you spot a mistake anywhere?
Let me try to see. So you said that the second term of the geometric progression is 54. The sum to infinity is this. The combination is greater than half. And the 10th term. So you said AR equals to 54. And A upon 1 minus R equals to 243. Okay, you put that as A.
Wait, I think I mistyped in the calculator.
Oh,
Minus
maybe.
243. 243 minus 54. Okay, that gives you... I forgot to put the minus sign. Okay. Remember, minus sign, guys. Okay, so this, when I factorize it with my funny calculator, gives me 0 is 3x minus 2 and 3x minus 1. Yes. So my values of x are 2 by 3 and 1 by 3. And since I know the common ratio, which is what I'm finding, value of x, value of r, by the way, value of r, it's greater than 1 by 2, so I'm automatically going to ignore 1 by 3. So since my ratio is 2 by 3, I can now find a. A is equal to 54 divided by 2 by 3. 54 divided 2 by 3. So a is 81. And now I can find the 10th term. I will do that in a different color again. U10 is equal to AR9, where A is 81 and R is 2 by 3 to the power 9. So answer is 81 times 2 by 3 to the power 9, which gives us this value. It says leave your answer in exact form, so I will leave it as a fraction. This is my value. So let's check the mark scheme. Yes. Sometimes they do give like weird looking answers. It's strange. Okay, first thing, 2 equations. Second thing, you somehow rearranged and got a quadratic. Wow. Okay. They did either quadratic for A or a quadratic for R. And with that, you need to find your factorize that. Right. Again, when you're doing quadratic stuff, don't just show your answers. Show one step of factorization, even if it's from your calculator, because there's a mark for that. Or yeah, maybe implied. This is one mark. Okay, that's all for that. And this is the last question here. Okay, you want to do
Should I
this one,
try this
Ramesh?
one?
Yeah, go
Yeah,
ahead.
sure. So it says that the first term of a geometric progression and the first term of an arithmetic progression are both equal to A. The third term of a geometric progression is equal to the second term of the arithmetic progression. So let's just take that down immediately. So if it's saying that the third term of the geometric progression, right? So that's going to be 8r squared equals to the second term of an arithmetic progression, which is going to be a plus d, right?
Yes.
And then let's take the second statement, which is the fifth term of the geometric progression, which is a to the power ar4, yeah, is equal to the sixth term of the arithmetic progression, which is a plus 5d. Given that all of the terms are positive and not all equal, find the sum of the first 20 terms of the arithmetic progression. So I think what my okay, you know what? That's a pretty tough question, to be honest.
Hmm.
I can
What
find
this
r in terms of d.
not all equal means for the geometric progression, that means the ratio is not just 1 and all the terms are same.
Oh, okay, that also makes sense.
Also means the
Positive.
common difference isn't 0. The common ratio isn't 1.
Mhm. Oh, okay. Hmm. I
Hmm.
okay. Immediately, I think of dividing both them to find r square.
Oh, I've done this question and nobody liked it. Okay, it's
Really?
yeah.
Oh, is it adding it?
No, no,
Or
no. What do you want to try? What's your first instinct?
um okay, I would actually try to find I would actually divide both of them. AR to the power 4
What?
divided by AR square.
AR to the power 4 divided by AR square.
So it's gonna give an R
Oh,
square in 4.
you've got it. You've got it. Yeah.
Oh, I've got it.
So
Okay. Let's try that. So
AR
it's
to
gonna
the
be 8.
power 4 divided by AR square is the same
Yeah.
as A plus 5D over A plus D.
So I'm gonna get R square equals to
Uh
A
huh.
that, right? But then let's see. Am I gonna put this R square? Okay, okay. I could put that back into the first equation that we had. So
Yeah, there you go.
so it's gonna be A square plus 5AD equals to A plus D.
All right, let's write all that down. A plus 5D over A plus D is equal to A plus D. Yeah,
And I'm just gonna multiply by A plus D on both sides, I think.
right. Like that.
Yeah. So it's gonna be A square plus 5DA equals to A square plus 2AD plus D square.
Equals A square plus 2AD plus D square. Yes.
And then I could just remove the A square from both sides, and it's gonna be equal to 3DA equals to D square.
Equals to D square. Divide both sides by D.
So it's just gonna be 3A equals to D.
Yes. 3A equals to D.
And I guess we could
Right.
just put in any of one of the equations to find the answer. Let's put it in the first equation, let's say. So it's just gonna be AR squared equals to 4D.
AR square equals to 4D.
Yeah, it's basically A plus 3A, so that's gonna be 4D. And I'm gonna make another equation, I think, of AR to the power 4. So it's gonna be AR to the power 4 equals to 16D. And so I'm just gonna get R squared as dividing both of them. R squared would be equal to 4. And R would be equal to 2. Plus minus 2, but I think in this case it's gonna be 2.
Plus 2.
And
Right. So we're
okay,
looking
with
for the arithmetic progression. So we need to find A and D. So we can do that
oh
now.
yeah, I think we kind of derouted. I derouted the
Yeah,
direction.
we like no matter. Let's keep
So
going.
if we've gotten the relation, right?
Uh-huh.
Oh, actually, we can, because we could put in one of the equations to find out D, I think.
Yeah, we can just put
So let's
4
say if, yeah, 4, right? So it's just going to be 4A equals to A plus D. Wait, that's not working. We need to find essentially D, right?
Hmm.
Oh,
I
wait, it
think we
says
could
in
use
terms of
this.
A. It says in terms of A, the arithmetic progression. So the sum
Oh,
of
right.
20 terms, right? So we could just go with S20 equals to 20 upon 2
T equals to, let's make some space for this.
20
20
upon 2
upon 2
times 2A plus 19D. But that
90.
D is 3A essentially. And then we
Yeah.
basically just expand that. So it's going to be 20A plus. You could just expand it. I don't have a calculator for that
Okay,
one.
okay. 2 plus 19 times 3 times 10. Okay. So S20 equal to 590a. So that's a big O. It's S20.
Damn, that was actually kind of a tough question. I think what I really saw with this question was that experimented with it, especially because I saw AR square and R to the power 4, and I was like, that's going to create R square. I was kind of unsure if would it even result in something, but at the end, it did show us a relation of 3a equals to d.
I remember doing this question. I'm not sure if it was on a test or on a past paper, but I was trying to square both sides, and I'm like, the a and the a square don't cancel, and I was getting mad. And it just turns out you need to be creative. You need to divide them. So
Honestly, I think
okay.
that this approach actually works in a lot of questions. Just trying to find the value of R by
Mhm.
canceling out the a's.
Well, yeah, exactly. When there's a ratio, you should be looking for dividing things. When there's an
Yeah,
R,
and yeah, that's what I saw. Like, I hated the a, so just get out.
exactly. Nice. So sum of
Let's
first
check the mark
20
scheme,
in terms of a, and would you look
and
at
that
that?
is
It is
correct.
one. Okay,
Yay!
even if you can't get rid of the a for some reason, make sure you write your first two equations so that you get marks at least for that something. There's mark for eliminating r or a or d, then writing the progression or finding d equal 3a, then your expression and answer. Awesome. So when you get questions like these, don't panic. Think about it one step at a time. Make equations and try to manipulate these equations. That's all that is for this topic. So thanks guys.
Yeah, thank you all for tuning in. We hope that you had a great understanding of the topic. You can get hold of the notes on the ZNotes website. The link would be in the description. And our social media handles are on display, so connect with us and feel free to drop any of your questions. And see you in the next upload. Thank you.